Saxon's Trig, lesson 29, beginning on page 197, is about the unit circle, very large and small number fractions, and quadrantal angles. In this first section, they want you to understand that if you take a right triangle and you're just dealing with this outer dot and you begin to rotate it around the 4-quadrant grid, it basically forms a circle. And so our right triangles are based, you know what, let's redraw that. Should look more like that, sorry. I broke that cardinal rule. We should not be connecting to the y-axis. We should be connecting to the x-axis. But the same thing applies. When I rotate it, it's forming a circle. So the right triangles form circles. And this leads into some application things later on in the book when they break the circle and kind of unroll it. But we're not there yet. We're just at the beginning. And so they are letting you know that if you rotate this, you form a circle. And we're going to come back to that later on. Part B completely changes gears and talks about very large and very small fractions. Now, I know that something like 0.0002, that's not much, but that is larger than 0.00002. That's much smaller. So the further out into the decimals that we go, the smaller the concept. If I create a fraction such as x over 4, the larger the number, dividing by 4 makes it smaller every time. So the division makes it smaller, but the larger the number, I would still gain two larger numbers. However, as my numbers decrease and this gets closer to 0, 0 divided by 4 is going to be 0. So limit is a word that you use a lot more in calculus, but they want to kind of introduce it here. So as you approach 0 for your x, you are going to get closer and closer to a limit of 0. Now, if you have 4 over x, then the larger the number you plug in here, the more you're dividing, the smaller that becomes. And as you approach 0, can you plug in a 0 to the denominator? No, that is undefined. So we don't have a limit because we're not going to touch 0. However, if I ignore that part and I go the other direction, we get a value. It's almost oh boy, I don't know why I'm saying this so badly. As you are approaching 0, you're never going to be able to use the 0, but you're going to get close to a concept because it gets very small, 4 divided by that. So actually, I feel like it gets closer to 4. But what they state is that if x is a positive, then the positive infinity, as the value of x gets closer and closer to 0, it's still remaining positive. Let's just leave that discussion at that. Basically, you can have a fraction that either gives you a limit of 0 or is undefined because you can't put a 0 in. It could possibly grow and grow and grow and be infinity, but they didn't do that here. Okay, part C is more of the application piece of this lesson, but we have already done the basis of this. However, here's the new little piece. It's in a 4-quadrant grid. And a quadrantal angle is what happens when the degree that I'm given is 0 degrees. I'm stuck on this line at 0 degrees, but I need a triangle, a right triangle, in order to do sine, cosine, or tangent. So if the problem would say find the sine of 0, you need to know whether you can or can't do that. So I need to draw the triangle in as I normally would, and I am traveling over on this line because this is the line that is the axis I'm on, so it gets a 1. But am I actually traveling up any? No, because I'm stuck on this line. This doesn't really move up, so I label it a 0. The side and the hypotenuse will always match on this kind. So it's a quadrantal angle if it's hitting one of the x-axes. So 0, 90, 180, 270, or 360. Those are going to be your quadrantals. So in the example that I quoted, if I want to find the sine of 0 degrees, that's going to be opposite over hypotenuse. So my opposite is 0. 0 divided by my hypotenuse of 1. This is kind of why they reviewed this. 0 divided by 1 is 0. So the answer is 0. If I do cosine of 0 degrees, that's ca. So the adjacent is 1 over the hypotenuse of 1. So the answer is just 1. Tangent of 0 degrees would be toa. Opposite of 0 over adjacent of 1. Any 0 divided by 1 is still 0, so that would be the answer. Now that we've kind of gone over the basics, if you would have gotten an answer that put the 0 in the denominator that we said we could not have, then you're going to say that it's undefined. So the tangent of 90 degrees ends up being undefined. All right, as we do these other examples, you will see the other quadrantals because we're going to do quite a few of them. So example 1 says, draw figures as necessary to find 3 tangent of 180 degrees. All right, so on our 4-quadrant grid, 0, 90, 180. So we know this is the line we're actually talking about. The triangle can be drawn in either the 2nd quadrant or the 3rd quadrant. I tend to draw in the first one that I should come to. So picturing going all the way around to the 180 means I'm going to put it in the 2nd quadrant. All right, so there's my 90 degrees. This is the line. I am traveling on this line in the negative direction, label it. I am not going up. I did say that the side and the hypotenuse should match. However, the hypotenuse should not be listed as a negative, so it's going to be positive 1. So we know we're doing 3 multiply with toa. So what is my opposite? 0. What is my adjacent? Negative 1. 0 divided by anything is 0. And 3 times 0 is 0. So the answer here, 0. All right, example 2. Draw the figure necessary to find, and there's an A and a B. The first one is 4 sine of 270, and the other one is 3 tangent of 270. So we know that we're graphing the same 270 for both of those problems. 0, 90, 180, 270. This is the line we're going to. I can draw it in the 3rd quadrant. That's where I'm going to draw. It's the first one that I would come to going around. Always connect to the x-axis. There's our 90 degrees. So this is going down. 1 is here. Down is negative for this quadrant. I did not travel over any, and this will match the hypotenuse of 1. The other thing I haven't said so far is that if you mentally collapsed this, if you did not travel over any, you are going down 1. That's why that triangle works, but I didn't point that out before. All right, so sine is opposite over hypotenuse. The opposite is negative 1 over the hypotenuse of 1. So we're going to have 4 multiplying with negative 1, and that will be negative 4 for A. Now let's do tangent of this one. Toa. Opposite is negative 1. Adjacent is 0. Uh-oh, problem there. I ended up with a 0 in the denominator. So we said that was undefined. If it's undefined, it doesn't matter what I'm multiplying it with. Undefined is the answer here because I can't do it. Then example 3. Sine of negative 135 degrees. And, oh, they put that parenthesis around the whole degree. It doesn't really matter. Plus 3 radical 2 with cosine of 180 degrees. So this one, when we graph it, we are starting at 0. Negative means I'm going to move this direction. This then becomes negative 90. I'm definitely past that. Negative 180. Nope, didn't quite reach that. So I know my triangle is going to connect to here. So this much is 135. How much is the gap then to get to 180? 45 degrees. Then we're going to label those memorized parts. Both legs will be 1s. Hypotenuse will be radical 2. Make sure you get the right signs though. Negative going down, negative going backwards here. Now sine is so we want opposite, negative 1 over hypotenuse, root 2. Okay, that's all I have there. Plus, And then this one is cosine of 180. So we need a different triangle, 0, 90, 180. It's this line. I'm going to draw my triangle here. There's the 90 degrees. I am moving over, so this is 1. Because I went backwards, it's -1. I did not travel up at all. Hypotenuse will be 1. Cosine is ca, so adjacent is -1 over hypotenuse of 1, so that's basically -1. So 3 root 2 times -1. This one is still going to be negative. I'm going to go ahead and do that radical 2 times radical 2 to fix the denominators. This is going to be negative radical 2 over 2 plus, and this negative multiplying is actually going to make that -3 radical 2, or you could have just written that as a minus, either way. To combine these, we need a common denominator, which will make this 2. Change this to a 6. So when we put it all together, negative root 2 minus 6 root 2 over 2. Ooh, now they're like terms. So this implies a -1. -1 minus 6 is -7 root 2 over 2. It does not reduce those outside numbers. I was looking for the final answer. It's on the next page. And they wrote the negative in front of the fraction. Same thing either way, whether it's in the numerator or in front of the whole thing. I think it doesn't get lost into the division line as easily if it's written in the numerator. It's just easier to spot than if I'm writing it here. My brain tends to sometimes add that as if it is the part of the division bar. So I don't like to write it there. I like to write it in the numerator.